Today we're on page 8 of our chapter 14 notes packet, and what we're going to do today is we're going to be solving triangles. And the question is, when do you use law of cosines and when do you use law of sines to find the missing values of the triangle? So we're going to get some practice on this. So we'll work through 4 problems, and the directions are to A, state whether each triangle should be solved by using the law of sines or the law of cosines, and B, solve each triangle rounding answers to nearest tenth. I'm starting with number 8. All right, so the middle of the page here, number 8. Looking at this triangle, we want to find x, and x represents an angle. And we have all 3 sides represented. As long as all 3 sides are represented, 99% of the time, that means you're going to use law of cosines. So for A, this is law of cosines. LC for law of cosines. Now for law of cosines, we start with the side opposite the angle. In this case, we're trying to find this angle x, so we start with the side opposite it. So 17 squared is equal to the sum of the squares of the other 2 sides minus twice their product times the cosine of the angle. Now we need to get cosine x and then eventually x all by itself. Now remember how we manipulate this. All right, get rid of the addition or undo the addition first. So we're going to subtract 6 squared and subtract 13 squared. So we'll have 17 squared minus 6 squared minus 13 squared equals negative 2 times 6 times 13 times the cosine of x. Next, this is all multiplication, and what undoes multiplication is division. So we're dividing by negative 2, 6, and 13. So we have cosine of x equals this fraction, 17 squared minus 6 squared minus 13 squared over negative 2 times 6 times 13. And now finally, x is going to equal the cosine inverse of the fraction. And let's go to our calculator. Make sure you're in degree mode. So second cos of our fraction, 17 squared minus 6 squared minus 13 squared divided by negative 2 times 6 times 13. And we're rounding to the nearest tenth. So this would be 122.6 degrees. So when all 3 sides are represented, that's a good indication that you're using law of cosines. Next, I want to do number 10. In number 10, we have here angle x, x represents the side of the triangle, and so we have 2 sides represented, and we have 2 angles. So we have the 2 angles and the sides opposite those angles represented. We have just 2 sides represented and the angles opposite them. This is going to be law of sines. So for A, this is LS, law of sines. And law of sines says we start with the length of the side opposite the angle, so I'll start with x, over the sine of the angle, over sine 29, equals, our other ratio would be 16.8 over sine 94. Cross multiply, x times sine 94 equals 16.8 times sine 29. Divide by sine 94, and we have x equals 16.8 times sine of 29 degrees divided by sine of 94 degrees. Go to the calculator. $16.8 times sine 29 divided by sine 94. Rounding to nearest tenth, 8.2. Is it reasonable? Yes. The 16.8 was opposite a 94-degree angle, so our 8.2, a much shorter side, is opposite a much smaller angle, 29 degrees. Okay, next I want to do number 7. Now for number 7, we have we've got two sides, and we want to find x, which is an angle x. We have an angle of 30 degrees, but we don't have the side opposite it. So we actually have to do something first before we can find x. Right? If I'm thinking of law of sines, 8 over sine x equals 5 over o. We don't have that angle, so we can't start with law of sines. We need to find, actually, we know this angle. We need to find this side first. Okay? We need to find this side first. So I think in this case we're going to do both. We're going to have to use both law of sines and law of cosines. So let's label this y, this side y. All right? So disregard the x for now. And if this is labeled y, then all three of our sides are represented. And we know the angle of 30 degrees is opposite our side of y. So we're first going to use law of cosines. So first, ls. No, I meant LC, sorry. So first, law of cosines. And law of cosines, you start with the side opposite the angle. In this case, we have the 30-degree angle. So that side squared, y squared, equals the sum of the squares of the other two sides, 8 squared plus 5 squared, minus twice their product, times the cosine of our 30-degree angle. I'm running into the other problem there. All right, so y equals the square root of this whole thing. 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 30 degrees. Let's go to the calculator. Square root of 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 30. All right, that's 4.4405. Right. My final answer for x needs to be rounded to nearest tenth. So do not round this to nearest tenth, because this is an in-between step. So it's good practice to keep 4 decimal places. All right, so 4.4405. So we're going to say that y equals 4.4405. Okay, now to find x, now we kind of have our options. And this is 4.4405. All right. Now all three sides, we know what they are. We could use law of cosines and start with 8 squared is equal to the sum of the squares of the other two sides minus twice their product times the cosine of angle x, right? But for practice, now I'm going to use law of sines, right? We could use law of cosines, but just so we get the practice of both laws, I'm going to use law of sines to find x. Right? So we start with the side opposite. So 8 over sine x is going to equal the 4.4405 over sine 30. Cross multiply. I'm running out of room here, so I'm going right to sine x is equal to, when I cross multiply, I get 4.4405 times sine x equals 8 times sine 30, and then I would end up dividing by the 4.4405. So x is going to equal the sine inverse of that fraction above. Okay? Let's go to the calculator. So second sine, alpha y equals 8 sine 30 divided by 4.4405. And we'll round this to the nearest tenth, 64.3. So 64.3 degrees is the value of x. All right, but wait a minute, something doesn't seem right here. Because if I was to put 64.3 in here, that would make this angle approximately 85 degrees, around 85 degrees. And then this is the largest angle, but that's not the longest side. So I better go back, and we use law of sines to figure out a second angle measure, so we better consider also the supplement of this. So 64.3 is not going to do it here, because that would be the middle angle, but 5 is the side length that is in the middle. So this angle can't be bigger. This angle here cannot be bigger than this one. This one has to be the largest angle of the triangle. So let's take the supplement of 64.3. So let's undo this circle. And the supplement of 64.3, I'll put this up here. So 180 minus 64.3 is going to get us the 115.7 degrees. So that's our value for x. And now that will make sense. Okay. And the next one I want to do, the fourth problem, is on page 9, which I seem to have misplaced my page 9. Here it is. Number 14. Okay. And the directions are solve each triangle. That is, find the measures of the remaining 3 parts of the triangle to the nearest integer or nearest degree. So number 14, in triangle ABC, I'll stop there, I'll draw a triangle. This is number 14. Lowercase a is 8, so the side opposite angle A is 8, angle B is 35 degrees, and angle C is 55 degrees. Okay, so what do we need? We need angle A and lowercase b and lowercase c. Well, angle A is no problem. We know two angles of the triangle. Add them up. 55 and 35 is 90. So angle A, 180 minus 90, is 90 degrees. Now I'll keep it alphabetical. If I want to find the side of length B, all right, we don't have the other side, so this is definitely law of sines. All right, this is definitely law of sines. So using law of sines to find the length of the side opposite angle B. So lowercase b over sine of 35 will equal 8 over sine 90. Cross multiply, b times sine 90 will equal 8 times sine 35, and I'll divide by sine 90, so b equals 8 times sine 35 divided by sine of 90. Now, since this was a 90-degree triangle, right triangle, could we go back and use our regular SOHCAHTOA? Yes, we could. Go into the calculator. Clear. Where's my clear button? 8 sine 35 divided by sine 90. You know what the sine of 90 is, right? Sine of 90, think of the unit circle as 1, so we're actually dividing by 1. All right, so the nearest integer or nearest degree, this is the length of a side, so nearest integer, 4.58 would round up to 5. So b equals 5. And now for C, right, I don't want to use something I found, right, because again, we had rounded this. So let me go back to the originals in working with, we originally were given the 8, finding the angle measure of 90, that is exact. And then the angle of 55. So I'm using law of sines again. So we're taking C over sine 55 equals 8 over sine 90. When I cross multiply here, I'm going to end up with C times sine of 90 equals 8 times sine 55. Divide by sine of 90. C equals 8 sine 55 divided by sine of 90. Just change that to 55. So we have 8 sine 55 divided by sine 90, rounding up to 7. So C equals 7. Okay, so there we had some practice using both law of sines and law of cosines. Again, when all three sides are represented, most likely you're going to use law of cosines. If not, law of sines. This concludes our video. Thank you, and we'll practice further on these 2 pages of the notes tomorrow.